Energy is not easy to define. Things have energy, but you can't hold a bushel of energy in your hands. You can see what it does, but you can't see it directly. There are different types of energy, but the differences between them are manifested only in how they make stuff behave. We do know that the total amount of all the different types of energy in the universe is always the same. Now, for chemists, two important types of energy are chemical potential energy and kinetic energy. Potential energy is energy waiting to happen. Think of a stretched rubber band. If you cut it, all that potential energy gets converted to kinetic energy, ow, which is registered by you as pain. Like a stretched rubber band, chemical bonds also store energy, and when those bonds are broken, that potential energy gets converted to other types of energy like heat or light, or gets used to make different bonds. Kinetic energy is the energy of motion. Now, molecules are always moving. They're not necessarily going somewhere, though they could be, but they are vibrating, stretching, bending, and/or spinning. Take methane, which is 4 hydrogens attached to a central carbon, as an example. Drawn on paper, it's just a still tetrahedron. But in real life, it's a jiggling mess. The kinetic energy of molecules is exactly the same type of energy as the energy you have when you're moving around, except that you can be still and molecules can't. If you suck the kinetic energy out of a group of molecules, they'll move less, but they'll never fully stop. Now, in any group of molecules, some will have more kinetic energy than others. And if we calculate the average kinetic energy of the group, we'd have a number mathematically related to temperature. So the more kinetic energy a group of molecules has, the higher its temperature. And that means that on a hot day, the molecules in the air around you are spinning, stretching, bending, and generally shooting around much faster than on a cold day. Now, hot and cold, by the way, are relative terms. They're always used to compare one thing to something else. So on that hot summer day, the air molecules have more kinetic energy than the molecules in your skin. So when those air molecules crash into you, they transfer some of their energy to the molecules in your skin, and you feel that as heat. On a cold day, the air molecules have less kinetic energy than the molecules in your skin, so when you crash into those air molecules, you actually transfer some of your kinetic energy to them, and you feel that as cold. You can trace the path of energy around you. Try it at your next cookout. You burn charcoal, and the release of that chemical potential energy shows up as extreme heat and light. The heat then makes the molecules of your burgers, your hot dogs, or your vegetables vibrate until their own bonds break and new chemical structures are formed. Too much heat and you have a charred mess. Just enough and you have dinner. Once in your body, the food molecules in your delicious or charred dinner get broken down, and the energy released is used to either keep you alive right now, or it's stored for later in different molecules. As night falls, the hot summer air cools, and the flow of energy into you slows. Then, as the air reaches your skin temperature, for the briefest of moments the flow stops. And then it starts up again in the opposite direction as energy leaves the warmer surface of your skin to return to the universe around you. That energy neither created nor destroyed, but ever shape-shifting, the chameleon phoenix of our physical world.